Okay, now let's look at our next analysis technique. And what we want to start looking at now is how we can take circuits and take certain elements and combine them together. And so we're first going to look at the topic of source reduction, how we can reduce multiple sources into a single source. And let's go start by showing how we can combine voltage sources together in series. And what I'm going to do is I'm going to use the principles of KVL and KCL to demonstrate this. Let's assume I've got a single loop circuit here with 3 voltage sources, and note all those sources are connected together in series. So I've got them connected together to some element, it doesn't matter what, but I'm going to define a voltage Vs across that element. Now what I'm going to do here is, let's look at these 3 sources. We notice the polarity of this one is different than those 2. What I want to do is I want to combine those 3 sources into a single source. In other words, I want to show that it is possible to take all 3 of those sources and to turn them into a single source like so, but I still have the other element and the same voltage Vs across it. So I want a transformation from this to this. Now in order to do this, what I'm going to do is I'm going to make sure all of these 3 sources are oriented with the same polarity as that source. Well, obviously this one is, so is that one. That one's not. Not a problem. As we already know, that's easily fixed. I can flip this around and call that minus 3 volts. Now that I've done that, I'm going to write a KVL equation. Start here and write a KVL equation around the loop. And what I'm going to get is minus 3 plus 2 plus 10. All rises must be equal to the drop Vs. And I add these together. Vs must be equal to 9 volts. Well, looking here, the voltage Vs is clearly also the voltage of the voltage source. Therefore, this is 9 volts. What do I see here? Voltage sources in series with the same polarity add together. So voltage sources in series add together. Now let's look at current sources. So let's say I have this circuit. So here I've got current sources in parallel. And in this case, this is 2 amps, this is 6 amps, and this is 1 amp. And what I want to do is I want to once again perform a transformation, where in this case I'm going to replace those 3 current sources with a single current source flowing in this direction. So the current's going to flow out and flow in, which means the current's going to flow out and flow in for those 3 in series, or pardon me, in parallel. So what I want to do is, let's take all 3 of these current sources and make sure they're going in the same direction. Since I want to do this going up, the 6 amp source is fine. Those 2 are not, but once again, that's an easy fix. Flip the arrow around. This is minus 2 amps. this is minus 1 amp. And now by KCL, I add those together. And KCL says that this current, I'll call this IS, which clearly must also be this current value IS. IS must be equal to minus 2 plus 6 minus 1 is equal to 3 amps. And so those combine together into a single 3 amp source. And in this case, current sources in parallel. Once again, same direction. If they're connected in the same direction and they're in parallel, once again, they add. The values simply add together. So I can now take a voltage source or current voltage sources or current sources and combine them, but I can't mix them together. I can't combine a current source with a voltage source. Now, of course, these are independent sources. Can I make this work with a dependent? Sure, as long as it's the same type. So, for example, can I combine two dependent voltage sources? Say 3V1 and 2V1? Sure I can. Add them together. They must be equal to a single voltage source of 5V1. So as long as the sources are the same type, independent or dependent, then I can just combine them together. All right? So sources is very straightforward. What about resistors? Well, let's look at series and parallel combinations of resistors next time.